Good day, future RMTs. In this video, we are going to discuss amino acids and proteins. To start with, our learning outcomes are as follows. Differentiate the structures and components of amino acids and plasma proteins, and to evaluate laboratory results in diagnosing amino acid deficiencies and abnormalities in plasma protein levels. To start with, I would like you to recall, the word amino acid is a general term referring to a two functional group joined together. We have here your amino group, your amine, and we have here your carboxylic group or your carboxylic acid. This amino acid or this compound is composed of what we call amino and carboxyl group, wherein that's the basic the basic unit of our proteins, the amino acids. Now, remember that these amino acids are alpha amino acids that are present in the protein. Generally, the purpose of our amino acids is for our cellular growth, repair, and maintenance. Like what I've said, amino acids is a composed of amine group or amino group and carboxyl group. This represents our protein. The basic or the amino acid is the basic structure of our amino acids. Now, when we said proteins, these are macromolecules. Okay? These are macromolecules composed of our link polymers rather of amino acids. And that link in the amino acid is what we called the peptide bonds. Okay, do you still remember your biochemistry, These peptide bonds, linked together, that is where our protein is being made of. Now, amino acids can be essential or non-essential. Hindi po ito lugaw, pero essential and non-essential amino acids. Now, what is the difference between essential amino acids from non-essential amino acids? When we said non-essential amino acids, these are amino acids that are produced from essential ones. Okay? Non-essential amino acids are produced from essential ones. Thus, therefore, if there is a deficiency in our essential amino acids, it leads to the deficiency also in our non-essential amino acids. Example of essential amino acids includes your valine, your leucine, isoleucine, and methionine rather. Okay? These are your essential amino acids. And those who are not belonging to this one are what we call non-essential. No. Aside from this four, we also have your tryptophan. Okay? Phenylalanine. Threonine, lysine, and histidine. Okay? These are our essential amino acids. Okay, the rest are non-essential amino acids. Again, when we said non-essential amino acids, they are derived from our essential ones. And usually, essential amino acids are coming from our dietary sources. We have what we call keto acids. Keto acids. What do we mean by keto acids? Keto acids is a removal of amino group from a amino acid. When we said amino group, diba amino group is C double bond O NH2. Okay? That's our amino group, right? The removal of amino group leads into what we call carbon-oxygen double bond. And as we all know, carbon-oxygen double bond refers to the functional group ketones. Because this removal of amino group will be substituted by other carbon. Thus, therefore, there will be a carbon double bond with oxygen, leading to what we call ketones. Why acids? Why keto acids? Because of our carboxyl group attached to the long chain of our carbons. Okay? Best example of keto acids are the three ketone bodies that can be found in our body. The acetone, the BHA, and the acetoacetic acids or acetoacetic acid. Those are examples of keto acids. Remember, that these keto acids are glycogenic to generate glucose precursors. That's why in cases of severe starvation, in cases of diabetes, there is also the presence of ketone bodies in the urine. Okay? Ketogenic to produce or to generate ketone bodies. Again, when we said keto acids, these are the removal, These are the removal of our amino group. When we said glycogenic, generate glucose precursor. When we said ketogenic, ketone bodies. Now, there is what we call glucogenic amino acids and ketogenic amino acids. What's the difference between glycogenic amino acids and glucogenic amino acids? So let's discuss. When we said glucogenic amino acids, these are amino acids, that can be converted into glucose via what we call gluconeogenesis. Take note, these are amino acids that can be converted into glucose in the liver via the process what we call gluconeogenesis. And if we still recall the definition of gluconeogenesis, this is a metabolical pathway or a metabolical process that converts non-carbohydrate compound to a carbohydrate to be a source of energy. Usually, this took place when carbohydrates level in the body is depleted, mababa, wherein the fats, the lipids, and other essential nutrients or essential molecules such as our amino acids converted to a glucose to become the sole source of energy. Thus, therefore, it is capable of forming glucose precursors. Take note also that glucogenic amino acids are important in gluconeogenesis. Well, of course, how could you transform or convert a amino acid into a glucose if it is not important in gluconeogenesis? Usually, our glucogenic amino acids includes essential and non-essential. Example of this one is our methionine. This is methionine or methionine is an example of a essential amino acids which is also considered as a glucogenic amino acids. Now, how about ketogenic? If glucogenic is important in the process what we call gluconeogenesis because it's conversion to become glucose, or because it can be converted to become a glucose via the process gluconeogenesis. How about ketogenic amino acids? When we said ketogenic amino acids, these are amino acids that form acetyl-CoA or acetoacetyl-CoA. Thus, therefore, becomes a precursor of ketone bodies. Okay? Example of our ketogenic amino acids includes leucine and lysine. Leucine and lysine are two amino acids that can be considered as ketogenic amino acids. Therefore, its metabolism, its conversion will give you acetyl-CoA and acetoacetyl-CoA. But aside from lysine and leucine, we also have your isoleucine, phenylalanine, tryptophan, and tyrosine. However, take note, leucine, ano leucine? Isoleucine, phenylalanine, tryptophan, and tyrosine are considered ketogenic amino acids and at the same time glucogenic amino acids. Okay? While your lysine and your leucine are only classified as amino acids. Okay? So these are the table that shows what are amino acids under glucogenic, what are amino acids under ketogenic, and what are those, ito pala, no? Isoleucine, phenylalanine, tryptophan, and tyrosine. Take note, considered glucogenic and ketogenic. Again, when we said glucogenic, no, precursor of glucose, and when we said ketogenic, precursor of ketones. Okay? Glucogenic amino acids, once converted, can be converted into glucose via what we call gluconeogenesis. And ketogenic amino acids is capable of forming acetoacetyl-CoA and acetyl-CoA. Now, what do we mean by amino acidophotist? This is just a recall of amino acid disorder or metabolic disorder of the new metabolic disorder, which involves our amino acids. Remember, at a normal state, at a normal condition, amino acids are just derived from another amino acid. No, the normal metabolism, for example, of our phenylalanine, no, converted to tyrosine, is a normal metabolism, a normal pathway which involves the phenylalanine hydroxylase that converts our phenylalanine into tyrosine. So that this tyrosine will be having its byproducts such as your melanin, your thyroxine, no? As you remember, thyroxine, take note of this, thyroxine, your thyroid hormone, no, is derived, no, a byproduct of our tyrosine, of our phenylalanine metabolism, no, a byproduct of our tyrosine, okay, as well as epinephrine. Thus, therefore, problem, no, or deficiencies in this enzyme could lead into what we call amino acidopathies. Usually, we have your PKU, MSUD, and homocystinuria. PKU stands for phenylketonuria. MSUD is maple syrup urine disorder. Okay? And homocystinuria. Now, these are examples of our amino acidopathies. Amino acidopathies, which means problem or deficiency or abnormalities in the normal metabolic pathway and the normal metabolism of our amino acids. All right. Like what I've said, let's say for example this one. Phenylalanine is converted into what we call tyrosine at a normal state through the enzyme phenylalanine hydroxylase. If there is a problem or a deficiency, the most common cause of amino acidopathies is the deficiency or lacking of our enzymes that will convert the amino acid to its other form of amino acid. Alright, going back. Phenylalanine in a normal state will be converted into tyrosine through the help of the enzyme phenylalanine hydroxylase. In a condition or in a scenario or circumstances that phenylalanine hydroxylase is deficient, there will be what we call accumulation of phenylalanine. Accumulation of phenylalanine will lead into what we call overflow. Why there's an overflow? Excess number of our phenylalanine in the body needs to be excreted. Because as you all know, the metabolism or the mechanism of our body is that when there is excess, we have to eliminate. And when there is an excess, we have to eliminate. Elimination is via urination. Therefore, there is a accumulation of what we call, accumulation of what we call phenylalanine in the urine, leading into what we call phenylketonuria. Okay? Leading into what we call phenylketonuria. Now, what will happen? What will happen? Yung tyrosine natin, deficit. Depleted, bababa. Deficiency in tyrosine can lead into a problem such as mental retardation. Another one is a patient with phenylketonuria will develop fair complexion. Maputi. Yung mga magulang medyo kayumanggi, pero yung mga anak, yung anak na mayroong phenylketonuria or PKU ay medyo maputi. Bakit? The answer on that, kung ang naiisip mo is because of the byproduct melanin, ay tama ka. That's correct. That's the reason why a patient with phenylketonuria will have a fair complexion. Pero yung nanay at tatay niya medyo maitim. Because of the byproduct deficiency in the byproduct melanin. Thyroxine, as we all know, a thyroid hormone is important in the neurological development. Okay? You might be wondering, bakit naging amino acid si thyroxine? Ano ba yon? Remember that thyroxine is a amino acid. No, that's the backbone. No? This is the backbone of thyroid hormones. Wherein iodine will attach to tyrosine to produce your T3 and T4. Now remember guys that mild PKU, mild PKU is seen wherein the phenylalanine level is between 600 to 1000 micromoles per liter. Okay? While non-PKU but considered as hyperphenylalanemia, is seen between 180 to 600 micromole per liter. Now, how about MSUD? MSUD is a disorder of decarboxylation of keto acids such as your leucine, isoleucine, and valine. Okay? These are the problem in MSUD. Okay? Thus, therefore, there is what we call accumulation of keto acids in the blood, in the urine, and even in the CSF that can lead into what we call mental retardation and death in infants. How about homocystinuria? When we said homocystinuria, there is an impaired enzyme activity resulted to elevated levels of homocysteine and methionine in plasma and urine. Okay? Plasma and urine. The problem in this metabolism is your homogentic acid oxidase. All right. We also have here your tyrosine. This is just a recall of our discussion in uh, AUBF. Okay, so we have type 1, type 2, and type 3. Type 1 is caused by the deficiency of enzyme Fa. When we said Fa, that is your fumaryl acetoacetate hydroxylase. No? Produces generalized renal tubular disorder and renal failure, liver failure in infants soon after birth. Type 2 naman, lack of the enzyme tyrosine aminotransferase, while type 3, lack of enzyme para hydrophenylpyruvic acid deoxygenase. Okay? How about for tryptophan disorder? Ito yung mayroong blue urine color. O blue color urine. No? Naglahok-lahok. Blue colored urine. Because of the abnormality, no, in the excess indican, no, in excess indole rather. Excess indole that converted into indican by the liver that can lead into what we call indigo urine or blue urine. Okay? Another one is malignant tumors, no, yung 5 excess 5 hydroxytryptophan, no, which can lead into a overproduction of serotonin that can lead into what we call overproduction of our 5-hydroxyindole acetic acid, which is your 5-HIAA. Example, kapag po meron tayong excess, too much consumption of banana, no, nakakameron tayo ng pseudo increase in 5-HIAA. Now, what are the methods of analysis for our amino acids, no? The method of analysis for our amino acids includes a fasting of 6 to 8 hours. Bakit may fasting? That's a good question, no? That's a good question. Why do we have to fast if we're going to measure the levels of our amino acids? The basic answer on that is because of to avoid the effect of absorbed amino acids originating from our dietary intake. No? Originating from our dietary intakes from our proteins. Okay? Next. Heparinized sample is the sample of choice for our method of analysis for amino acids. Samples should not be hemolyzed. Why? If the samples are hemolyzed, no? If the samples are hemolyzed, magra-rupture yung red cell. Nandun yung mga proteins. Yung proteins is composed of what? Amino acids. Okay? What else? WBC amino acids are 100 times higher than in plasma. Okay? 100 times higher ang WBC amino acids than plasma. Kaya kung magla-lyse lang tayo dyan, no, it could also affect our amino acid levels. Take note, don't aspirate platelet and WBC to prevent contamination. And the most important thing to consider is that we have to deproteinization. What do we mean by deproteinization? Removal of proteins. Why do we have to do this? We have to do this to ensure that our sample will not be contaminated by the proteins because these proteins will cause falsely elevated levels of our amino acids. Bakit? Eh yung amino acids mo nga, yung backbone niya ay proteins. Okay? Remember that deproteinization must be done within 30 minutes after collection and perform immediately or store at -20 to -40 degree Celsius. For your analysis, we can also do that, no? Okay, we also have your TLC or thin layer chromatography and your MSMS or your mass spectrophotometry, your tandem MSMS, which is high sensitive and high specific for our amino acid analysis.